Hello. This video I'd like to do a little bit on percent yield. Percent yield, basically what ends up happening is when you do what I previously described in a previous video as a mass-to-mass problem, and let me pick a different color for my pen, you would be given the mass of one thing and figure out how much mass of a product would be coming out of the reaction. The problem is that's kind of a theoretical thing, and what ends up happening is you don't always get that amount. So percent yield basically is a stoichiometry problem with one additional piece of information. They tell you you actually got a certain amount, and then it's just a percentage type problem. So let me just do one as an example. Let's say in the previous videos I kept starting with hydrogen. Let's just, for something different, let's just start with the oxygen here. And let's say that I tell you you are starting with I don't know, let's call it say 40 grams of oxygen in your reaction here. My question, the first part of a percent yield problem is how much product you get out of the reaction, and then the other thing, and this would be given to you, you would be told in the problem how much you actually got. So let me just pick a kind of a random number, and let's say I really get 33.5 grams of water. So you'd be told, here's your reaction, you're starting with 40 grams of oxygen. You really get 33.5. What is the percent yield? So what we do is we figure out how much we should get and then compare that to what we actually got. So let me go through this. What you do is you start out with, and again I'm comparing moles of this to moles of this, but I wasn't given moles. So I'm going to take my 40, and let's just, for the sake of significant digits, let's call it 40.0 grams of O2 times, and what I'm going to do is I'm going to go from grams of O2 to moles of O2, and remember we always do 1, and I'm going to put the molar mass here. Well, for oxygen, the molar mass, each one is 15.999. I've got 2, so 16 times 2 effectively is 32.0 times in a line. Now that I know the moles of this, by taking 40 and dividing it by this, I now know the moles of oxygen. Well, I know that the number of moles I have here, I'm going to have twice that number of moles of water. So notice what I can do. I go from moles of O2 to moles of H2O, and the numbers here come from these coefficients. And again, to make that clear, let me do that maybe in a different color. 2, and there's nothing here, so that's basically a 1. So my first step here was to turn, and again let me highlight even that in a different color. My first step was to take what was given to me, which in these problems generally be given to you in a mass. This is the process of turning my grams into moles, and then I go from moles of what I started with to moles of what I was trying to find. Notice that this part here is always 1 mole over my conversion. Since I was given mass, my conversion is molar mass. And let me go back to red here, and now I can go from moles of H2O to grams of H2O, and again notice it's 1 per my conversion. The conversion goes on top, and again this is molar mass. The molar mass for water, again oxygens are 16, hydrogens are 1 each, so that would be 18.0 grams. So if I go through and do this, and forgive me just for the sake of convenience, I'm going to actually do this on a calculator. I would do 40 times 2, I'm going to do the whole, go all the way across the numerators, 40 times 2 times 18. And I get a syntax error. I must have done something wrong. 40 times 2 times 18 is 1440 divided by 32. I get 45. Okay, so this, what I'm getting then is 45. And go back to your original. This had 3 significant digits. All these are considered conversions, so I don't really consider them in my rounding. So I'm going to take this and write 45.0 grams of H2O. Okay, so now what this tells me is that, and let me change colors here for the percent yield portion of this. We'll go to purple. If I reacted all 40 grams of oxygen, I theoretically would get 45 grams of water, assuming I had excess, I had tons and tons of hydrogen, so that wasn't a problem. So I should get 45, but they're telling me I only got 33.5. So what you do is you just do a percent yield. And the way this works is you say, well, I actually, according to the problem, got 33.5 grams. I theoretically, based on my calculations, should have gotten 45.0 grams. So all you do is you take the 33.5 over the 45, and since this is a percentage, we do the times 100. And so let me 33.5 divided by 45 times 100, and I'm getting 74.444 repeating, so we'll round that to 74.4%. So the correct answer to the problem is my percent yield is 74.4%. And again, I got that by calculating the mass that I should have gotten, comparing that to, and this is always given to me in the problem, how much I actually got to get my percent yield. So that's all you do.